Hello everyone, and then welcome to another video. Okay, so in this video we'll be treating some examples, okay, some exam based examples or problems on analysis of structures, most importantly on method of joins. Okay, right. So without further much ado, let's dive right into this tutorial video. Okay, so in case you are new to this channel and then this video end up being very useful to you, I would urge you to subscribe to the channel, hit on the bell icon so that you don't miss out on any uploaded video. Like the video, share, and then let us know your questions in the comment section. Okay, so we've been given what certain body, so we are to determine the forces in each member of the truss. Okay, then we have to indicate whether the members are in what tension, okay, either in tension or compression. Okay, right. So whenever you are given such an example, you need to draw the free body diagram of each of the sections. You have to determine the forces. Okay, so let's do that. So let's start from one point and then we move towards another portion. Okay, right. So let's start from let's look at the free body diagram for each of the sections. Okay, so we have free body diagrams, okay, of each of the sections. So let's start from maybe section B. That's where we have our force. Okay, so it's better to start from that section. Okay, right. So when you are drawing the free body diagram for section B, this is how it will look like. Okay, so we have this force going downwards. Okay, so we have certain force going downwards, and then we have our 500 newtons. Okay, and then we have this portion. Okay, right. Okay, so this is moving upwards, this is moving in this direction, so we have 500 newtons. Okay, this for B. Okay, we started at B because that's where we were certain of a certain force which was already given. Okay, so we have FBC, because this is B and C. Okay, and then most definitely this would BA. Okay, so we have FBA. Okay, this is very simple. Okay, now let's look at the forces. Okay, so we take the forces, summation of forces in the x direction and then summation of forces in the y direction. Okay, so let's take the summation of forces in the x direction. Okay, note that whenever the force is moving in this direction, okay, it's positive. Okay, so whenever it's moving in the opposite direction, is negative. Okay, so now let's proceed. So we have a certain force, 500 newtons, moving in that direction. So we have 500. Okay, and then we have this force moving in the opposite direction. That's for y. Okay, we are concentrating on x axis, only x axis. So let's look at BC. Okay, so BC can move in either the y and then x axis. So let's take for the x axis. Okay, so whenever you are taking force for the x axis, you take it with respect to sine. Okay, right. So from here you know that this is 45 degrees, so most definitely this portion will be 45 degrees. Okay, this is 45, so most definitely this will be 45. Okay, right. So we have this will be minus FBC. Okay, and then we have sine of 45 degrees. Okay, after that you equate that to 0. So we have to find the FBC, that's the force. Okay, so when you do the computation, when you do a simple calculation, okay, move this one to the other side or either move FBC to the other side, you end up with FBC force of 707 newtons. Okay, so for FBC, from here you could notice that this force was moving towards the B. Okay, so it means that this is a compressive force. Okay, this is a compressive force because the question stated that we should indicate whether the forces are in tension or compression. Okay, so this is a compressive force. So in case you don't remember, these are how the forces will look like. Okay, so we have this force, this compressive. Okay, and then we have this is a tension. Okay, pulling the body apart. Okay, Now, so this is what compression and this is what tension. So let's move on to another joint. Okay, so let's take joint B. Okay, so we have let's say joint C. Okay, so we first draw the free body diagram for joint C. Okay, so this is where we are trying to find the forces. Okay, so we have this point. Okay, these are joint C. Okay, so let's see the forces acting. So we have this force. Okay, and then we have this force. Okay, right, so we have this force. So we just name this X. So we have what C, sorry, so we have CY, and then we have what a certain force of what FCA. Okay, CA. Okay, so we have CA, and then we have another force acting in this direction. Okay, so that's this force FBC. Okay, right, so we have FBC acting in this direction. Okay, FBC, and then we already know that FBC is what 707. Okay, 707 newtons. Okay, this becomes a bit simpler. Okay, so we take the what the forces in what the X and Y direction. Okay, now note that we only took the forces in the what X direction for this question, so you could also take the forces for what Y direction, so that this question becomes a bit simpler. Okay, so we have what, let's take the forces for the Y direction. Okay, let's equate that to 0. Now whenever the force is moving upwards, we have what positive. Whenever it's moving downwards, we have what negative. Okay, so let's see, FBC is moving downwards, so most definitely it's what, sorry, FBA, so most definitely it's what's negative. Okay, and then we have FBC. Okay, so whenever you move FBC towards a Y direction, it's always what cos. Okay, keep those things in mind. Whenever it's towards the what Y direction, it's most definitely cos, and then X direction is most definitely what sine. And then you can verify that from what your SOHCAHTOA. Okay, you can verify that from what your SOHCAHTOA. Okay, right, so let's proceed. So we have what FBC. Okay, FBC cos what 45 degrees, because this is what 45 degrees. Okay, 45 degrees, right? And then you have a FBA, which is acting in the opposite direction. Okay, so FBA, negative FBA, and then we equate that towards 0. Okay, so when you do the simple calculation, we know FBC to what 707. Okay, so we have what FBA, okay, to be equal to what 707. Okay, cos of 45 degrees, and then we end up with what an angle of a force of 500 newtons. Okay, so this will be in tension. Okay, this force will be in tension because it's pulling apart from what the joint B. Okay, so this joint B, it's moving apart from what joint B. Now let's proceed from here. So now let's take the forces in what in the X direction. Okay, and then we equate that to 0. So you know that forces acting in this direction is what positive, so the reverse would be what negative. Okay, so let's see, we have what, let's look at what forces acting in the what X direction. So we have what FCA. Okay, so FCA is moving towards the what right. Okay, but let's just make FCA moving towards what A. Okay, let's make FCA moving towards A so that the understanding will be better. So since there is a force moving towards A, okay, so let's just make FCA towards A. Okay, right, so when FCA is moving towards A, it means that FCA is what negative. Okay, so we have FCA, and then let's look at the other forces. Okay, we have FBC. Okay, so let's say FBC move in the what X direction. Okay, so X direction we have what plus, that's why initially I stated that you have to use your what SOHCAHTOA. Okay, right, so we have FBC, that's what 707. Okay, and then we have what an angle of what 45 degrees. Okay, these are 45 degrees. Okay, right, and then you equate that to 0. Okay, so now So here, from here, you can notice that we have what? This is what we have, okay? And then we have this angle, okay? And then we have what? 45 degrees over here, okay? Right. That's how it looks like. This is how FBC looks like. So when you use your SOHCAHTOA, so this is K, okay? Cosine, so we have what? Cos theta of the adjacent over the what? The hypotenuse. So we take the what? Adjacent and what? Hypotenuse. So we have most definitely this will be at 90 degrees, okay? We are moving towards the x direction, so most definitely this will be what? A cosine. So we will take from what? The x instead of what? The y direction. That's why this is what? Cosine, okay? Right. So let's proceed from here. So we have what? FCA, okay? FCA to be equal to what? When you take when you compute this, okay, we have negative FCA to be equal to what? Negative 500 newtons, okay? So most definitely FCA will be equal to what? 500 newtons, okay? And then this in what? Tension, okay? FCA is pulling apart from what? Is pulling away from what? The sea, okay? Pulling away from the sea. Okay? In case it was pulling, the force was pulling towards sea, that would be what? Compression, okay? Now let's proceed towards the y direction, okay? So y direction is equal to 0. Anything upwards is what? Positive. The reverse is what? Negative, okay? Right. So we have what? That means we have only cy, okay? Cy is positive because it's acting upwards, okay? And then we have what? FBC, which is acting downwards, okay? So that's negative, okay? 707, okay? And then we have what? Sine, okay? We have sine of 45, and then we equate that to what? 0. And then we have what? Cy being equal to what? 500 newtons, okay? So when you compute this, it's similar to this, okay? But this will be what? 500 newtons, okay? Right. So let's proceed from there. Then let's move on to what? Joint A, okay? Let's look at joint A, okay? Let's draw the free body diagram for joint A, and then we proceed from there. So we have what? Joint A, okay? So this is how joint A will look like, okay? We have joint A over here, and then we have what? A certain force acting downwards, AY, and then we have an upward force, okay? Upward force over here, so that's FAB, okay? Or FBA, okay? FBA, okay? And then we have what? Force acting in this direction, that's what? FCA, okay? And then we have another force acting in this direction, that's what? AX. Note that FBA is already known, FC is already known, okay? That this is what? 500 newtons. And then we have what? 500 newtons, okay? Right. So let's do the simple calculation. So summation of all forces in the x direction to be equal to 0. So we have what? All x forces. So we have FCA, which is what? 500. And then we have what? AX, which is what? Acting in the opposite direction. Okay, so most definitely AX will be what? Equal to what? 500 newtons. Okay, and then let's look at what? The forces acting in the what? Y direction. Okay, so forces acting in the Y direction, most definitely we have FBA to what? 500. Okay, and then we have what? AY acting in the opposite direction, so we have AY, then you equate that to 0, and then we have what? AY also being equal to what? 500 newtons. Okay, right. So this was very simple. Okay, now let me clarify this. Okay, now this is what we have. Okay, in case you have any force acting in this direction. Okay, so let's say a force acting in this direction. Okay, and then we have maybe an angle of what? 30 degrees, and then it's acting in this direction. Okay, now whenever you want to take the force, okay, this is how you take the force. Okay, you use what? So and what? K. Okay, So for the that's sine of what? Theta to be equal to what? The opposite over the what? Hypotenuse. And then we have the cosine of what? The adjacent over the what? Hypotenuse. Okay, so from here this will definitely be what? 90 degrees. Okay, so when you are taking the sine, okay, whenever you are taking this, you have what? The opposite. Okay, so this is what? The opposite. Okay, so let's say this x and this what? Y, and this what? Z. Okay, so opposite is what? X. Okay, divided by the hypotenuse, which is what? Z. Okay, and then we have our theta. So theta is what? 30 degrees. Okay, and then whenever you are taking for cos, okay, the cos would be what? The adjacent. Okay, which is y, and then divided by what? The hypotenuse, which is z, and then we have angle still being what? 30 degrees. That's why some of these forces act in what? X and what? Y. Okay, and then we have their respective forces. Okay, right. So let's proceed to the second example. Okay, right. So we have to determine the what? Determine the forces acting in all the members of the truss. Okay, shown below. Okay, right. So we have I didn't indicate this, but there is this force is what? So let me draw the free body diagram for this. Okay, and then we get to understand that. So we have when you draw the free body diagram for this, we have certain force. Okay, you have certain force acting in this direction. Okay, acting in this direction, which is what? 1.5 kilonewtons, and we have another one acting in this direction, which is what? 3 kilonewtons. Okay, I'm drawing only the free body diagram for these portions. Okay, because these have been already drawn. Okay, and then we have this what? At point A, and then we have what? At point C, we have only one force acting in this direction as what? 1.5 kilonewton. Okay, this is point C, so this is point A, and then this what? Point C. Right. So and then we have what? We have 2 meters and then what? 2 meters. Okay, 2 meters. So total of what? 4 meters. Okay, but at an interval of what? 2 meters, 2 meters. Now let's proceed from here. So we have what? Let's see how we go by what? The solution. Okay, let's see how we find the solution. Okay, so let's start from where we have forces acting. Okay, so let's start from maybe point C. Okay, right. So or joint C, because we are dealing with what? Joints. Okay, so with joint C, okay, we have lots of forces acting. Okay, lots and lots of forces acting. So we have this force. Okay, that's the 1.5 kilonewtons, and then we have what? X-axis. Okay, x-axis. Now we also have what? Y-axis. Okay, right. So let's see, we have what? 45 degrees and what? 30 degrees. Okay, 45 degrees angle and 30 degrees angle. So let's indicate that over here. So we have what? A certain 45 degrees. Okay, right, and then we have what? 30 degrees. Okay, right. So these are the 45, the 30, and then 45 degrees. Okay, now most definitely this would be what? F what? CB. Okay, FCB, and then we have what? FCD. Okay, this D. So we have what? FCB. So CB and what? CD. Okay, so we have what? FCB and what? FCD. Okay, right. Right. So this is quite simple now. So we could just proceed. Let's indicate a force direction. Okay, now let's proceed. So we have what? Forces acting in the what? X direction being equal to what? 0. Okay, so anything acting in this direction is positive, the reverse is what? Negative. Okay, right. Let's start from FCD. So FCD is moving from the X axis, so we have what? Minus FCD with an angle of what? Okay, X direction. Okay, so we have what? Cos 30 degrees. So when you use SOHCAHTOA, you end up noticing that there's what? Cos. Okay, so FCD 30 degrees, and then we have what? FCB. Okay, FCB at an angle of 45. Okay, so this would be what? 30 plus 15. Okay, because we are we are concentrating on what? The angle acting in what? In the x-axis. Note that this is 45 and this is what? 30 degrees. So most definitely this will be what? 15 degrees, because the whole of this portion has to be what? 90 degrees. Okay, right? So we are taking from FCB to this point. Okay, right? So this will be FCB, and then we have what? Cos of what? 30 plus what? 15 degrees. Okay, then we equate that to 0. Okay, right? So you can notice that we have what? System of equation. This looks like a system of equation. So let's simplify this further. So we have FCD cos what? 30 degrees plus FCB, okay, cos 45 degrees, okay, equal to 0. So this will be what? Equation 1. So let's move on to what? The y direction. Okay, so anything upwards is positive, reverse is what? Negative. Okay, so we have what? 1.5. okay, this is 1.5 kilonewtons. Okay, and then we have what? FCD acting in what? Y direction. So most definitely your guess is as right as mine. Okay, that's what? Sine. Okay, so we have FCD sine of what? 30 degrees. Okay, sine of 30 degrees, and then we have what? FCB. okay, FCB acting in what? The y direction. Okay, so we have what? Minus FCB. okay, so now it will act downwards. Okay, opposite from what? Our main direction. So that would be also what? Cos 45, even though we are taking the angle of what? 45 degrees. Okay, right, as a reference. Okay, degrees, okay, and then we equate that to 0. Then we end up with what? Another what? System of equation. Okay, so now all you have to do is to just pick up your calculator and then solve these two equations simultaneously. Okay, so once you solve these two equations simultaneously, you end up with what? Both forces for FCD and what? FCB. So you end up with FCD to be equal to what? 4.098 kilonewtons. Okay, and then FCB, okay, will also be what? 5.019 kilonewtons. Okay, now FCD will be what? Pulling apart. Okay, so we have what? A tension force, and then FCB also compressing. Okay, so we have what? A compressive force. Okay, now let's proceed to the final portion of this question. So we are taking what? At point A. Okay, so we already know for all the forces at point C, so most definitely they might be quite opposite to what? A. So let's take what? At point D. Okay, let's take the forces at point D. Okay, so for point D or joint D, let me draw the free body diagram first. Okay, so for point D, so joint D. Okay, joint D, we have what? This is the free body diagram. Okay, FBD. Okay, so we have what? This portion, this is D. Okay, now so we have, so D, there is a force acting upwards towards what? B. Okay, so that's the force over here. So most definitely you know that would be what? FDB. Okay, and then again we have what? These angles. Okay, 30 degrees, 30 degrees. Okay, right, so we have these angles. Okay, so we are taking reference at what? X-axis. Okay, so we have 30 degrees and what? 30 degrees. Okay, right, and then this will be what? Forces. Okay, this will be forces. So this will be what? This will be FDA. Okay, FDA, and this will be what? FDC. Okay, and then note that we already know FDC, which is also the same as what? FCD. Okay, so this is what FDC or what FCD, which is already what 4.098 kilonewton. So we are left with what FDA, okay, and then what FDB. Okay, so we are left with what this force and then what this force. So let's take both forces in the x and what y direction. Okay, so now we have what forces in the x direction being equal to 0. Then that will give us what FDA. This is acting opposite to what to x direction. So we have what minus what FDA. Okay, we have what angle of what that's cos 30 degrees. Okay, right, and then we have what our force, which is FCD, also okay moving in this direction, so in the same direction as the x axis. Okay, so this is moving in opposite direction to the x axis. Okay, FD, and then FDC is moving the same direction with what the x axis. So we have what 4.0 okay 98 okay, and then we have 30 degrees, so that's what cos 30. Okay, right, so let's equate that to 0 and then find what FDA. Okay, so when you do the simple computation, okay, you end up with, when you punch this on your calculator, you end up with what a force of 4.10 kilonewtons. Okay, so you could just run this. Okay, when you run this and then you divide that by this this angle, you end up with this force. So FDA is what pulling apart. Okay, so this is what tension. Okay, it's pulling from the D. Okay, so that's tension. And then let's look at the forces acting in the what y direction. Okay, so upwards is what positive, downwards is what negative. So we have what FDB. Okay, FDB acting in the same direction as the what y axis. Okay, and then we have what both this force. Okay, so this force is also acting what in the y direction. Okay, but opposite. Okay, so this what 4.098 and then this what 4.10. so we have what minus 4.098. okay, and then we have what sine of what 30 degrees plus what FDA, which is also what 4.10 okay sine of what 30 degrees. Okay, right, and then we equate that to 0, then we end up with what FDB to be equal to what when you do the simple computation or calculation, you also end up with what FDB being equal to 4.10 kilonewtons. Okay, and then we could notice that FDB is also pushing or acting opposite or from what D, or acting away from D. Okay, so most definitely that will be what a tension. It will create a tension force at what point D or joint D. Okay, right, so I think this was very useful. Okay, in case you have any other questions, you could just leave them in the comment section and I'll reply to them as soon as possible. Right, so have a lovely day and I'll see you in the next video. Bye bye.